Kia ora Year 10. In this video I'm going to go through the unistructural and multistructural questions from the JAF practice on algebraic expressions. So there are 17 questions. I'm going to go quite quickly. If you're a Year 9 watching this, there's a lot of overlap with the Year 9 and Year 10 algebra content, but I'm going to go a little bit faster than I do in my Year 9 videos on this one because it should be revision. So let's start with these simplify questions. So simplify a plus a plus a. So these are like terms, so that gives us 3a. Question 2, I'll just write it out again. We've got 3x plus 2y plus 13x plus 10y. So what can we put together? Well, the 3x and the 13x can go together, and the 2y and the 10y can go together. So that gives me 16x plus 12y. Now we move on to multiplication. So q squared times q cubed can be simplified to q to the power of 5. I've got the same base, that means I can just add the powers. So I'm just going to do one example of why that works. Q squared times q cubed can be written out the long way as q times q times q times q times q, and that gives me q to the power of 5. Now that's really tedious, we don't want to have to do that too often, so we need to get very familiar with the rule that if the bases are the same, we can just go ahead and add the powers. Okay, number 4, 4a squared times 3a is equal to 12a to the power of 3. So this 3a here is 3a to the power of 1. Writing that one out the long way, we get this. But by the time you're revising, you shouldn't need to do that, but that just might be a memory jog for something you've seen earlier. Now, the order in which we multiply doesn't matter, so I can multiply the numbers first, and I get 12 times a times a times a gives me a cubed. Okay, so I'm multiplying the numbers together, and then I've got the same bases, so I can add the powers, add the 2 and the 1. Question 5, it's a division 1. 18a squared divided by 9a gives me 2a. Now again, if we write that out like this, we'll see what's happening here. So 18 divided by 9 gives me 2, and a divided by a is just 1, so that's where the 2a comes from. Question 6 is x squared all cubed. So I'm going to write this out the slow way. It's x squared times x squared times x squared. So we've got 3 lots of 2, which gives me x to the power of 6. So when I've got a power to a power, I multiply the powers together. Number 7, 5a squared b times 6a cubed b squared. Now it's not that common these days in textbooks to see this full stop meaning a times sign, but it comes up sometimes, and it's in this example. So we could rewrite that as just a big multiplication sign here. We do the numbers first, so 5 6s are 30, and then I've got a to the power of 5 times b to the power of 3. So remember that this b here is b to the power of 1. Right, on to the next few. Oh, we've done number 7 already. Okay, and then number 8, 24 ab to the power of 4 over 8b simplifies to give me 3 here. I've got an a here, but I've got no a's down here, so it's 3a, and then I've got b to the power of 4 here, divided by b to the power of 1. So I can look at that and subtract 1 from 4, I get 3a b cubed. Right, number 9 and 10 are 2 substitution questions. So when we do substitution, we should show our substitution. So a plus b in this case is equal to 2 plus 3, which is 5. Question 10 is 3 times a minus b. So that's equal to 3 times 4 minus 2. Whenever we do substitution, we have to be thinking about BEDMAS. So here we're going to evaluate this first. This is a very easy one. I know you're going to do this in your heads, but let's just show the working nicely. So we get 3 times 2, which gives me 6 for my answer. Okay, on to the last 7 questions. So these are all expand questions and factorize questions. If you're watching this video and you can't remember how to do them, I've done some Year 9 playlist videos on both expanding and factorizing. So if you just search on the channel for expand or factorize, you should find those videos. Or go to the 9 Mat Algebra playlist. So when we expand, we're taking this number and we're multiplying it through here. So we have 2x plus 6. For number 12, it's the same idea. It's 2 times this, which is 6x, plus 2 times this. That gives me 8. The next one is 2x times x minus 3. 2x times x gives me 2x squared. Take away 2x times 3, 6x. Okay, number 14 is the last of the expanding ones. So negative x times 2x gives me negative 2x squared. Now I have negative x times negative 3 gives me plus 3x. The next set of 3 questions asks us to factorize. So when we factorize, we're looking for the highest common factor and we're working systematically with our numbers and with our variables. The highest common factor for the numbers is 3, and I don't have any more common factor to take out. So it's 3 times what will get me 3x, 3 times x, plus 3 times what will get me 6, 2. Next one, a squared plus 4a. Well, there's no highest common factor in the coefficients because I've got 4 here and I've got an invisible 1 here. But here I've got a squared and here I've got a. So I can remove the a. Now we work backwards and we say a times what gets me back to a squared, a times a, plus a times 4. Right, last one, factorize 2a squared minus 8a. This time I've got a highest common factor in the coefficients, which is 2, and I've got a highest common factor in the variables, that's a. So 2a times what will get me 2a squared, a. Take away 2a times what will get me 8a, take away 4. Okay, so that's that set of unistructural questions done. I'm going to move on and do the relational questions in a few minutes. Thanks for watching.